I want to verify that the infinite series converges. So we have the sum of 1 over n times n plus 1 from n equals 1 to infinity. So this one, we want to break it up. So what we're taught is to use the partial fraction decomposition, but there's actually a much easier way to do this. So first, I'm going to show you the shortcut to add fractions. So let's say if we have 1/3 plus 1/2 plus 1/3, the way to add this is to multiply the diagonal and then add when you multiply the other diagonal, and then the denominator you'll have the two numbers multiplied. So let's say if I want instead to subtract, the only difference here is I still look at the diagonal. I do 1 times 3 is 3, but now it's going to be minus 2 times 1, and then it's still going to be 2 times 3 in the denominator. And notice that this is 1 over 2 times 3, which actually, funny enough, it looks like what we have here. That'll be 1 over n times n plus 1, where n is 2. So 1/2, you can write it as 1 over n. 1/3, we'll just write it as 1 over n plus 1. So this is another way to do that. Okay, so this will be sum from n equals 1 to infinity, 1 over n minus 1 over n plus 1. And this looks like a telescoping series. So it's always good to write out first couple terms, see what's happening. So when n equals 1, we have 1 minus 1/2. When n equals 2, we have 1/2 minus 1/3. And then when n equals 3, you have 1/3 minus 1/4, etc. Do this infinite number of times. So what we see is that the 1/2s are going to cancel, 1/3s are going to cancel, the 1/4 is going to cancel with the next one, etc. So everything is going to cancel except the first term, or the first number here. So the sum is just 1. And the trick here is that because the difference between in the denominators is n, the difference here is just 1. From n to n plus 1, the difference is 1. Therefore, you're going to have only 1 left over. If the difference was 2, you would have 2 left over.